Hey, what's up, Joel? So you are now going to be moving on to systems of linear equations, and there's three different ways in which we can solve systems. One's by graphing, elimination, and then substitution process. I'm going to teach you about the graphing systems today. I was originally going to try to teach you all three in one day, but I don't want to push that too far because some of them can kind of get confusing. So we'll just do graphing today, and we'll keep you updated. So graphing systems, and so I'm hoping that you remember how to graph, right? We've been working on this for quite some time. That y equals mx plus b. That b, so this 1 in your equation is your y-intercept. And then that m, the number or variable next to your x, is your slope. Okay, so we're going to go at 1 and then up to over 1. You got your point right there, okay? If you're looking at this other equation here, you can see that it's not completely simplified into the equation y equals mx plus b. So what you really need to do is get your y isolated, right? So you subtract x on both sides, and then you divide everything by 2. So your slope would be negative 1 over 2, and then your y-intercept would be 6, right? And then you could graph that. And so let's kind of keep going on this. And so our objective today is to solve systems of equations by graphing, solve systems from the real world, and then our vocabulary, of course. So systems of linear equations, solutions to a system, and point of intersection. So let's kind of build on this. And so we have solved equations like 2x plus 4 equals 12, right? We've been doing those linear equations. You would divide by everything by 2, or I mean, you could add 4, and then, we've been working on linear equations quite a lot, okay? We also have found many solutions to equations like these, right? Putting them in y equals mx plus b form, and then solving like that. And now we will be finding one solution to two equations together like this, okay? That's what systems are, two equations that we find one solution for. So vocabulary, systems of linear equations is a group of two or more equations that are linear, using a set of mark like this to group them. So let's think about our introductory activity. What did you learn? So to get one solution, you need the same number of equations as variables. So we have an x and a y, we have an x and a y, we have two equations. In this one, we have an x, y, z, x, y, z, x, y, z, three variables, three equations. W, x, y, z, W, x, y, z, W, x, y, z, W, x, y, z, four variables, four equations. You kind of get the idea. And so how do we solve systems of graphing by graphing? So here are the steps. Step 1, graph both equations. Step 2, find the intersection. And then step 3, check your answer, right? We always want to check your answer because if we're able to do that, we want to ensure we get a correct answer. Why not, right? And so we always want to make sure that you solve for y first, all right? We always want it to be in the form of y equals mx plus b in order to graph it. So we had to solve for y. All right, so let's do this one. Solve the system by graphing. And so we can easily graph this bottom equation, y equals 2 over 3x plus 2, right? We have our y-intercept already, and we also have our slope of rise 2 over 3. And so let's kind of go through our steps of how we would do this. And so if we were to graph this red line, we would first need to put it in a y equals mx plus b form, right? And you would subtract 2x on both sides, Subtract 2x on both sides, so now you're looking at 3y equals negative 2x plus 18. And then you would divide everything by 3 to get that y completely isolated, to get it in the y equals mx plus b form. And so your slope would end up being negative 2 over 3. And then your y-intercept will end up being 6. Okay, so if you're looking at this line here, we're crossing at 6. It's a little off, that's my bad, but it is crossing at 6. And then you're going down to, down to 1, 2, and then you're going over 3. 1, 2, 3. Down 2, 1, 2, over 3. 1, 2, 3. And now you're getting that line. And we also need to graph this blue line. You have a y-intercept of 2, but our slope is rising. And there it is. Okay, now your answer for this question of when your two equations have a common solution is where they cross. Well, these two lines, I know it's a little bit off, but they're crossing at 3, 4. So when x is 3, y is 4. So we can plug in x into both of our equations and then y in both of our equations and solve, and it will come out as a true statement for both equations. Okay, we have one solution for two equations, and that is 3, 4. Watch next video.